Is everyone able to see my screen? Okay, that's great. Before I start, just wanted to give you a brief introduction about myself. Some of you already know me, some of you probably don't. I'm Kelsey, the education manager for VEX Robotics. I'm in charge of supporting educators and students in APAC region. And I've been working in the education industry like for over 12 years. Before, actually, I was in English language content development and teaching and teacher training. And then I moved to STEM. I know a lot of teachers, you don't have any background in coding or robotics. You don't need to worry about that, because for myself, as an example, I used to be an English teacher and trainer, and now here I am in STEM. I've been several years in STEM. If I can do it, definitely all of you can do it. For today's session, what we hope you to walk out today, there are several things, key takeaways for you. The first one is, I would like everyone to know or to appreciate that education robotics is a tool for improving students' attitudes towards STEM. And we wanted to help you understand, how to help students to implement robotics in primary school settings with VEX GO. So today we'll be emphasizing a lot on VEX GO. Of course, if you have other, questions about, secondary school products, you could let me know in the Q&A session. And the other thing, the other takeaway I would like to help you understand is the robotics is the solution, but not the challenge. I totally understand a lot of teachers think robotics is super challenge, and it's not easy to get started, because even for educators, it's a challenge. But I hope you walk away after today's session, understand it's quite easy to get started, even you don't have any background in robotics or coding. Before we talk about, the robotic itself, I just wanted to give you a very brief introduction of who we are. We are an educational robotics developer of hardware, software, and curriculum that is used around the world for students, K-12 students. We emphasize a lot on the progression from kindergarten all the way to career level. And we founded in 1996. Our headquarters is the US, and here I am in Hong Kong supporting educators in APAC region. And our engineering team and education curriculum development team are based in the US. And we have different offices around the world. What we are also proud of is we are the world's largest robotics competition organizer. We understand that the ultimate assessment for a lot of students studying in the VEX STEM program is to design, build, and code a robot. And a lot of them, they want to solve one of our annual robotics challenges, and winners, they can go compete in the world championships. And students, they get a lot of chance to meet with students around the world. It's a very good way for them to communicate, with students around the world and to appreciate culture and diversities. Those are some of the images we took during our World Championship. Students, they got really excited to participate in this kind of event. Talking about STEM attitudes, there are a lot of research has been done about STEM, K-12 STEM education. And there are a lot of important takeaways when you dig into this metadata about STEM research. There are several points I wanted to point it out. The first one is students' attitudes, their attitude towards STEM actually decrease through the through the school year. They become less interested in STEM. A lot of research probably can see here. It's both for boys and girls. When they get older, their interest in STEM and their confidence in STEM actually decrease. So our students, they are born to be creators. They're born to be, they are interested in STEM naturally. But when, school years with this progress, a lot of them got decreased their interest. Why is that? Because a lot of times the schooling disabled or dismotivated a lot of students in the STEM. So support is very critical to help students perceive a positive attitudes towards STEM. And a lot of times there are misconceptions, and we really want to break those misconceptions. Those misconceptions impact students' perception and interest in STEM. Probably you can see from the research, the data, 50%, this data is from US, but a lot of times it's pretty similar around the world. 52% of Americans, they don't pursue STEM because they perceive that it is very hard. This is too hard. And for many individuals, perceptions is reality. 80% of students, they make a conscious decision by 8th grade whether they think they are good at math and science. That the research has been done, some research mentioned 8th grade, some research mentioned 4th grade, and a lot of other research mentioned, I found a research done last year, even as young as 4 years old, kindergarten years, they have already started to form perceptions about STEM. So as educators, we really want to encourage our students and foster positive attitudes towards STEM. And what we wanted to say is educational robotics has the potential to become a cornerstone of STEM education for its ability to provide hands-on, project-based learning through interdisciplinary curriculum. And there are a lot of ways to integrate robotics curriculum with STEM subjects. And the ultimate way we encourage to integrate robotics into every single subject of STEM is not only as standalone like robotics club. The most effective way would to integrate robotics into different STEM subjects. There are other research has been done. For example, this one has done by Australian Education Bureau, and they've actually found, students' confidence in STEM subjects are pretty low compared to other subjects. And if we want to overcome those challenges in STEM integration, I wanted to use a quote from an educator and psychologist about self-efficacy and confidence and attitudes towards STEM. To overcome challenges in STEM, we wanted to emphasize actually all students can become STEM learners and achievers. They can have high achievements in STEM. The principal limitation on what creative people can accomplish is what they think they are capable of accomplishing. All students, for example, are potential creators who could experience the joy that results from creating something new. But first, students must believe in themselves and their potential. It's the same for their creativity, their attitudes towards STEM, and of course, other learning areas as well. Another quote I wanted to mention is from our education director. He has just published a book, Jason McKenna. He's the VEX education director, just published a book about what can STEM do to your classroom. What is STEM? He mentioned that STEM is a mirror that reflects our world and its complexity. So by encouraging students to be curious, to see failure as an opportunities, and to not be afraid to make mistakes, teachers can help sustain their students' sense of wonder about the world. And STEM education helps students connect what they learn at school with what is happening in the world around them. So actually, STEM is an integrated subject and help understand, perceive the world they live in. And just mentioned a moment ago, this can happen as early as kindergartens. And we have done a lot of research about how STEM or how robotics could help students in different ways of teaching and learning, and also help educators. After today's session, or even, now you could go to our website to have a look. It's research.vex.com. We have done a lot of research about robotics and coding in this area in K-12. Especially, I wanted to mention one. It's about VEX GO. That's for the students from age 8 to 12. We have done this research with a school. About 100 and over 100 students participate in this research, and students are ranging from 3rd to 5th grade participated in our research project to identify if their perceptions of STEM topics could change after 6 weeks of robotics curriculum. And I will also show the 6 weeks of robotics curriculum with you because all our teaching and learning resources are online for you to have a look. So students, they were given a pre-survey to evaluate their attitudes towards STEM on different subjects of STEM, math, science, engineering, and also 21st century skills. So each grade then finished the robotics curriculum using the VEX GO product, which I will be sharing a lot of learning and teaching resources with you a bit later. And after the 6 weeks, we have found, you can see the data here, their perceptions and their attitudes towards every single subject, math, science, engineering, and even the 21st century skills, because not only we mention STEM, we emphasize a lot on soft skills as well, critical thinking skills, creativity, and also, teamwork and persistency. So this is just a research we have done, and then I wanted to share with you the product or the platform, the resource I wanted to emphasize today, the VEX GO. Before that, I just wanted to give you an overall picture about VEX Continuum. At VEX, we feel that the use of robotics and computer science in STEM education is a great driver to help students become creators using technology, but not just consumers, because nowadays everyone is a consumer, but we want to and enable students to be creators of technology. And from kindergarten all the way to career level, we have a STEM solution for students. For students as young as 4 years old, we have this VEX 1, 2, 3, and then all the way we have VEX GO and VEX IQ. That's the plastic construction system. What we are going to talk about today is VEX GO. That's a plastic construction system to help students to do a lot of STEM projects, and they can create, build, and code their robot. And then move to the higher levels, VEX EXPV5 or WorkCell. Those are the metal construction systems. So students, they use real world tools and fasteners to create and build their robot and then to program it in an advanced way, more advanced than 1, 2, 3 or VEX GO. We've also got a virtual robotics platform I will share with you a little bit later, because it enables educators and students to do hybrid teaching and learning. They can program their robot on a virtual environment. What we wanted to emphasize here is the progression and scaffolding. So students, they can progress all the way from kindergarten and towards the career level, university level. Okay, so why we want to teach STEM with VEX GO? VEX GO is the project, the platform students ages 8 to 12. This project, this platform, it teaches the fundamentals of STEM through a lot of hands-on and fun projects. Students see them really motivating and interesting. And we just mentioned STEM starts early. We really want to introduce education robotics in an early age. So young students, they can benefit from an integrated learning context and develop more positive attitudes towards STEM subjects. And this is a hands-on construction system. It's the same for all our other platforms, especially for VEX GO. It's easy for little fingers. It's a snap together construction system. And the whole STEM lab activities I will be sharing with you a little bit later, our resource for teachers and students. Usually one lesson takes about 40 to 45 minutes, and it's easy to build. Compared to, IQ, that's for higher grade students or, junior school, secondary school students. Compared to that, it's easier for smaller hands, this VEX GO. And the student-led, all of the activities we emphasize are student-centered learning, and most of the activities are student-led. Minimum instructions are needed. In terms of the presentation, the organization of the VEX GO, we have education kit. One kit, there are two boxes, one box with plastic parts and the other one with electronic parts and motion components. Or there is classroom bundles, because a lot of times for classrooms, for schools, we would recommend classroom bundles. There are different kinds of, classroom bundles, small classroom bundle or, large classroom bundles, but in every single classroom bundles, you can see it's easier for classroom management. We have the carrying bags, carrying cases, and robotics field, and also a lot of posters for you to post on the walls, and like parts posters. When students, they need to locate some parts, they can refer to those posters on the walls. And we've also provided this field tiles. For field tiles, there are different ways you could set up the field. It depends on what kind of activities and what kind of learning objectives you want to achieve. And you can do the, the U-turn or the racetrack if you want to ask students to compete with each other using VEX GO. Yeah, and how can you teach STEM with VEX GO? We usually recommend 3 broad steps for you to teach VEX GO. The first one is build it. Students, they can create and then build their robot. That's the first broad step, build it. And the second one is power it. Students, they can charge their battery, they can add the batteries and switch to their robots to power their robot. And they don't need to, use the electronic devices to code them in order to help their robot to move. That's the second broad step. And the third one is code it. For code it, students, they can add the brain. It's just like, human brains. It's tells the robot what to do. So the robot brain is something similar. So they can add the brain and then code it, and adding all those sensors to the robot to code it. Here, the 3 broad steps, what we also wanted to emphasize is the same as the scaffolded progression to students. Okay, so I will be sharing with you some examples for each steps. The first one, build it. For build it, we built the unpowered super. This one is an example from STEM lab material. It's called unpowered supercar. And for this one, you can see students, they can build this unpowered supercar in less than 10 minutes. It's pretty easy for them. And then we can ask students to do some experiments with the unpowered supercar they have done. And they can measure and record the distance the empowered supercar travels in different scenarios. So students, they will be able to learn how to predict an object's continued motion, change in motion, or stability. And there are a lot of other scenarios you can use and you can change. For example, you can put this in a ramp and then ask students to test and measure the distance they traveled on in ramp. And another example is to build, this one is a manually operated robotics arm. Probably you can see, oh yeah, here is animation. Students, they can build a manually operated robotics arm to explore what a robotics arm is and how it works. This one takes longer to build. The previous one, Power Supercar, only takes less than 10 minutes. For this one, like 20-30 minutes for students to build. And they don't need to, power it. You can still move it manually using a knob. They can still be able to learn, the engineering design process, and they can learn about the math, for example, the math behind the arm's angle, and also identify the movements of the robotics arm and its limitations. This is another examples I would like to share with you, how to build, how to teach them with, the first broad step, build it. And there are a lot of other builds we've provided teachers and students with. It's all on our STEM lab. It's education.vex.com. And for this one, it's builds.vex.com. And there are all kinds of, build instructions we provided teachers and educators with. For example, if you want to teach students about simple machines, you will be able to find some teaching ideas and lessons related to that. For example, in the middle, that's an inclined plane. It's also, known as a ramp, and that can be set at 3 different angles. And we can ask students do a lot of experiments to explore the friction and force. That's something students, they can learn physics using VEX GO. Those are just some teaching ideas we provide you with, simple machines. And if you want to teach science, there are other lessons available for you. If you want to teach, biology, to teach students about frog life cycle, we have lessons there for you. We can build the frog, in different life cycles. So students, they would be able to understand the whole life cycle, the biology of a frog. And if they want to, we want students to learn about magnets, and we can ask them to build this magnet car. It's really easy to build. It only takes about also like 5 to 10 minutes to build this. And after they have done the building, they can do all kinds of experiments using this build. And there are other examples about teaching math using VEX GO. For example, in the middle, you can see this is a clock. And we can ask students to build this clock, and then they are able to explore how 2 gears work together to transfer energy and also affect movement. They will be able to understand, the math, the time, how to tell the time using this, and they would also be able to understand the gear ratios and everything, the engineering behind that. Talking about the build instructions, here is just an example of from our build instructions. They include a parts inventory, so students, they can gather all materials needed at the start of the building process. For example, here you can see they need 18 red pins and 3 orange standoffs, and they can collect everything at the very beginning before they start building. And then we provide the step-by-step visual images. There aren't any words there in the build instructions. It's for, visual support. We have this before and after image. You can see it's pretty easy to navigate, especially for young kids. They, probably the first 2 builds, they would take some time to navigate. And after the first 2 builds, they would, understand how to do it really easy by looking at those build instructions. And this is just one example of the build instructions. And then talking about the parts, the VEX GO kits. This is a kits poster, and we also provide you with an interactive parts poster. Everything is online. For the interactive parts poster, if, especially for educators, if you don't know what does it mean by, for example, a pin or a standoff. Apologies, the network isn't that great today. If you want to know what does it mean by angle beam, you just click to it, and then there are detailed explanations there about, every single part. So we have provide you with this interactive parts. Okay, let's go back to the PowerPoint. As probably you can see here, everything is color-coded, so it's easy for students to locate the parts. And you can also see everything is color-coded. For example, the yellow ones are smaller than blue ones. So it's for all different kinds of parts. It's the same. Always the yellow one are smaller than the blue ones, and the red ones, they are always the smallest. So by that way, students, they don't need to remember the names, or, they don't need to count how many holes there. They can just, it's really easy for them to navigate, and it's easier for teachers to do the instructions as well. Okay, so that's those are some examples of how to build the robot. Of course, we want to encourage creativity for students. So for Build It, we provided some sample instructions there and some sample models. And the ultimate goal is to help students create their own robot. And then they can do all kinds of creativities, all kinds of builds with the parts. And the second step I wanted to say is power it. What does it mean by power it? For power, it means can add the switch. Okay, this one doesn't move. Okay, yeah. It's add the switch and also battery and motor to your build, and enables you can drive your robot using the switch, motor, and batteries. And then students, they would be able to understand what causes force and how can it be changed. And students, they will explore how using rubber bands compared to a battery and gears affects the speed of the car. And we can also, for example, you can see we can put two green gears here, and we can replace that with one green gear, and then, you know, the blue gears, the small gears drives the big gears, or, you know, the bigger gears drive the smaller gears. That way we can help understand what does it mean by, you know, increase the speed or increase the torque. They can do all kinds of experiments with that. And to charge the battery, it's really easy. It's just a USB-C cable, and you can charge that with the same cable you do with your not iPhone, but, you know, Android system, Android phones. So it's pretty easy. And if you have the classroom bundle, you can charge all your batteries together, all 6 of them, using this cable. And another example about power it. Here you can see we've got 2 switches to control. One of them, one switch and motor to control the base movement of the robotics arm, and the other one is to control the robotics arm itself. And then students will be able to understand how a robotics arm works. That's a simulation of industrial robotics arms, and they can learn all the engineering principles behind it. Those are just 2 examples I would like to provide you with about power it. And the third broad step is about code it. So code the robot. And how do robots work? A lot of times students, they wanted to ask this question. So robots follow step-by-step instructions known as algorithms. And we have to code our robots using the VEX Go, and to perform all different kind of behaviors. And so for this VEX Go, there are you can access it with different devices. For example, if you just use your laptop, it's completely online. codego.vex.com. If you go there, you will be able to see codego.vex.com, and everything is online. Just give me a second. Here it is. That's the platform, and you can connect that with your robot pretty easy. And everything is really easy to navigate. If you want to know how this platform works, you can click on to tutorial, and there are a lot of videos help you navigate how that works. As you can see, we have
with VEX Go, you can program
tutorials here to let you know. And we've also got a lot of sample projects. If you click this file and then open examples, you would be able to find a lot of sample projects there. For example, if you want to know how to code the carrying, like code your robotics arm to pick up a disc, and you click onto the project, example project, and then you would be able to find the detailed explanation in the sticky notes. That's a description of this project, and then some sample codes. And through those sample codes, it would help you understand how you can code the robot. So this whole platform is pretty easy to navigate. And during coded, that process I mentioned, we provided you with a lot of build instructions. You can also be able to access it here. If you click into the builds, it will lead you to all the build instructions for VEX Go. Yeah, for if you want to build a robotics arm, you could click into that. And if you want to build, a supercar or motorized supercar, then you could click to the build instructions. We've got 2 different kinds of build instructions, the PDF version. This is the PDF version. Yeah. go through that very quickly. All the parts you need are listed there, and the before and after image. It's pretty easy to navigate. And we've also got the 3D build instructions for some key builds, and they have the 3-dimensional image, the visual, to help students understand the builds instructions. Yeah, apologies, it's pretty, the network today is not that good in my office. It takes some time. Okay, yep, here it is, and that's the step-by-step 3D instructions. It's really easy for students to navigate. Okay, let's go back to the PowerPoint itself. And if you're using iPad or Android tablet, you can download this app, VEX Go. Okay, so talking about code it, you have to add the VEX Go the brain to your robot, and also you can code 3 sensors. There are 3 sensors available for VEX Go: the LED bumper sensor, electromagnet sensor, and also eye sensors. So there are 3 sensors available. I will give you some examples of different sensors. The first one, LED bumper sensor. This is an example. LED bumper sensor, what are some of the the key functions? The bumper sensor is used to detect physical contact, and also it's able to display colors. In this example project, it demonstrates how it is used to detect physical contact. So the when you press the LED bumper sensor, the car will start driving. You can see it's pretty easy to understand, the whole concept and the function of that. There's another use for function for LED bumper sensor. It can display colors. You can set your bumper to red, green, or no color. So that is a function of the LED bumper sensor. Yeah. We got a question about, does the VEX IQ have online built step-by-step instructions? Yes, for all our platforms, we got step-by-step build instructions, but not for the 3D visuals for IQ. For IQ, it's just the PDF version for the step-by-step instructions. Yeah. Okay. And next sensor I wanted to mention is this LED, sorry, not LED, it's electromagnet sensor. The electromagnet sensor is used to have your robot to be able to pick up and drop discs. You can energize your electromagnet sensor to boost or drop the disc. Let me see if I'm able to play this video. It's not, no worries, I have the video later.
In this example,
okay, and this sensor is eye sensor. An example about eye sensor. So eye sensor is used to detect if an object is near, and if so, determine the color of that object. You can see it can detect red, green, or blue, detect different colors. And the code base, for example, in this project, the code base will drive forward until it sees the red discs. Let me play again. Yeah, it will stop driving when it detects red. Yeah, so that's just one example about eye sensor. And here I wanted to share with you is the use of electromagnet sensor and eye sensor. You can see we have electromagnet sensor that's energize pick up the disc, and we've also got the eye sensor here at the back. So when the eye sensor detects different colors, for example, here, when it detects green, it will pick up the disc and turn right for 90 degrees. And if it detects red, it will turn right for 180 degrees. And it will, if it detects blue, it will turn left. So you can code it to perform different behaviors for the robot. And for this video, this is another example. Teachers can use robotics arm to teach industrial robotics, the concept of industrial robotics arms. The students, they can, combine several robot arms together in a project. You can ask students in different groups to work together, and they can code the robot to transport the discs. And this is a great opportunity for students to learn about collaboration, both, student collaboration, and at the same time, you can see the robot collaborate with other robots independently without human intervention. So that's the concept of automation, the very simple one, automation. Yep, so that is a quick introduction about the 3 steps: build it, power it, and code it. And next, I wanted to share with you the most important thing. That's the teaching and learning resources, especially as educators. I used to be a teacher. I understand, we don't have a lot of time to design lessons for, every single class, especially, for robotics. It's not your main, English or math or class. You want to spend, minimum effort to design those curriculum. So we provide everything for you. If you can see here, that's the website, education.vex.com. All our teacher resources are there online to help you teach and learn. We provided you with teacher's notes, pacing guide, student-facing materials, build instructions, content standards, and much more. Here, I wanted to show you is the pacing guide. I will go directly to the website after, a quick introduction from the PowerPoints. I just wanted to give you a quick summary first before I walk you through the website. For example, usually when we design your school year or semester, we would start with pacing guide. You can see there are different standalone projects. All our materials, projects, they are standalone project-based learning. They're projects. Each unit, there are around 4 to 6 labs. And you can see the builds there, what kind of build it involves, and the primary concept, the secondary concept, and whether it involves coding or there's no coding involved. So this is the scope and sequence for the VEX GO curriculum. In terms of the actual teaching and learning materials, there are 20 STEM lab units, 20 plus STEM lab materials there. I didn't put the exact number here because we keep updating. We are keeping updating those curriculum, so we are keep adding more resource to it. And there are currently 20 plus units. Each unit, there are 2 to 6 lessons, and each lesson is about 40 minutes. And we've also got 65 activity lessons as well. Those activity lessons, I will show you some examples. They are the extension of the STEM lab unit, the main unit. We provided you with more, extensive activities for you, during your open days or, after school clubs. You can use those activities. And we provided the materials in all different subject areas. Besides for STEM, we've also provided you with activities in social studies, literacy, geography, design, or arts. So no matter you are an art teacher, STEM teacher, or, even geography teacher, you would find related content on our STEM lab materials. This is just one example of the unit. It's called physical science, this unit, and there are 5 lessons in this unit. As you can see, each lesson is about 40 minutes. And you can see that's the scaffolding. And they can build the first one in 10 minutes and then do some activities with that. And then they add the power it, add the battery, the motor, and switch to it. And then they add the brain, and they can also add the sensors to it to code it. For each lesson, the lesson flow is about engage, play, and share. For the engage part, students, they are introduced to the key STEM concepts and knowledge. For example, they need, about a balanced force, where they need to learn about the concept of force. And then they need to complete a hands-on building experience. Usually it takes about 20 minutes. And the second step, the teaching step, is play. So we provided students and teachers with activities that can provoke STEM thinking. They will use the build they have done, the model they have done, to do different kind of experiments and document their findings, and do all kinds of creative and problem-solving tasks. That's the second part. It's about 20 minutes as well. And then the last part, we didn't count it as the 40 minutes because you can add, extra time to it. That's share. So students, they make their learning visible through demonstrations and discussions in the share sections. We provided you with some templates. Students, they can do some presentations to share what they have done, what they have learned in these lessons, or sometimes it's discussion. So students, they would discuss within groups or teams. That's where we want to help students with their self-efficacy and to help them with, their confidence and other soft skills. And usually it's about 10 to 15 minutes preparation time, for the each lesson. We really wanted teachers to have minimum effort, to prepare a lesson because we understand how busy teachers are. And what I will show you later about this. And for VEX GO, each unit, we've also provided a certificate for students. You can type in student's name and then, print it out, and you can hand it in to students, to parents. A lot of times parents, they wanted to know what their kids have done at home. Okay, so let me go to, I've gave you the summary, and then I wanted to go to the actual STEM lab itself to give you a walkthrough. Sorry, I just wanted to turn it off because, wanted to make it as quick as possible. Yeah. Education.vex.com, that's our STEM lab resource. If you click into VEX GO, those are the VEX GO resources I mentioned. I mentioned about pacing guide. I've opened it here for the pacing guide. You can see it leads you to the actual unit. For example, this unit, Introduction to Building, and there are 6 lessons available for this unit. And what kind of build and involved? If it says free build, it means creativity. Emphasize a lot on creativity. Students, they can do, all kinds of builds themselves. If there is a suggested model for build, we would put it here, for example, adaptation claw or, other like clock. Yeah. And the primary subject for that unit and the secondary subject, and what we want students to achieve, for example, science, simple machines, force and motion. Yeah. Whether it involves coding or not. And this will lead to the actual unit itself. Let me click into that. For example, simple machine, if you go there, it will lead us to the unit itself. For example, the simple machine, there are 4 lessons available in this unit. I wanted to quickly walk you through the materials. If I click into this lesson, inclined plane, you can see the goals and standards. We mapped all our curriculum and the key learning objectives. We mapped all our curriculum to international standards. For example, it depends on, each lesson. Basically, we've mapped our curriculum to NGSS standards, CSTA standards, British National Curriculum, Next Generation Science standards, and a lot of different standards. And the summary page, you can see what I wanted to emphasize here for the summary page is we have prepared all the materials, list all the materials you need. The most important one is this one, image slideshow. If I click into that image slideshow, that's the student-facing PowerPoints. You can see everything is Google document, Google PowerPoint, Google Slides here, and you can download it and edit it on your own. And there are a lot of videos available there as well. Everything is there for you, and you can download and edit it on your own. Yeah, and we've also provided you with some worksheets. Every time after students, they've done their build, they've done their experiments, they need to record their data on, for example, this one is the data collection sheet. We've done everything for you. That's the data collection sheet. Okay, let me go back. And down here, if you want to filter by subject, if you want students to learn math, and then you can filter by subject here, click math, and then you will be able to find all math related units there. Yeah, and one more thing I wanted to mention about resources, this activities, because I mentioned besides for the key units, we've also provide you with activity lessons. Activity lessons, they function as standalone activity, and you can, extend your lessons using those activity lessons. Those are one page. It's really easy. Let me, for example, this unit, this activity, usual activity lesson takes about like 40 minutes as well. It's just one page activity, and we've got step-by-step instruction. For example, this lesson is about asking students to create and build a house and do some experiments. Well, let's stay up during a windstorm and let's find out. And then they can understand the engineering behind it, how to make your house as stable as possible. That's the activity lessons. Okay, and one more thing I wanted to show you is the storybook. If you go to the teacher portal, I click into that, and the storybook, we want to introduce robotics to students using stories, and that's related to their daily life, and it's easier for students to understand. You can see this storybook, this PDF. You can download it and print it out for your students. It's theme related, and we've introduced this astronaut to students. Let me show you what I mean. What does it mean by, robots? And we've also included some safety measures in the storybook to help students understand. And everything is online. I just received a very good question. Henrich asked, do teachers need to create an account to access the resources online? No, you don't need to create an account. So everything is education.vex.com. Let me just send it to you in the chat box, and you would be able to access it anytime, anywhere, and you don't need to register an account. This is education.vex.com. We talk about VEX GO, so you click into VEX GO, and then you'll be able to find all the resource I just shared with you. It's the same for all our other platforms as well. Okay. Yes, that's the resource I wanted to share with you. And the last thing before we wrap up, I wanted to share with you is our virtual robotics platform, because we also want to emphasize hybrid teaching and learning, especially post-COVID. A lot of times we use websites, or we use hybrid teaching and learning. Students, they would access some teaching learning resources at home. This is our virtual robotics platform. We developed this platform during COVID to help students, and you can see there are different kinds of virtual playgrounds available. The first one on the left is the maze. They can use the sensors. The virtual robots, they are equipped with eye sensors, distance sensor, bumper sensors, and gyro sensor, basically all key sensors, and they can navigate through the maze. And on the right, that's the another coral reef cleanup activity. So we provide students with different kind of virtual playgrounds, and they are able to see all the real-time immediate feedback on the robot, on the dashboards, like the distance between the robot to the object, and whether the bumper sensor has been pressed or not. So that's the virtual robotics platform, vr.vex.com. And we've also provided you with curriculum resources about that. If you want to learn about computer science, block coding, level 1 block coding, using the VEX Go VR, you can do that. If you want to learn about Python using the VEX Go VR, you can do that as well. The cs.vex.com. Everything is there. And besides talking about the virtual robotics platform, we've also provided you with this pacing guide. We talk about VEX Go, the key unit, the name of the key unit and the description of the unit, we've also included the related VEX Code VR activities. So you can teach students about the physical robot, do some activities with the physical robots in school, and at home, they can run some activities using VEX Code VR platform. Yeah, because we recognize the keys to hybrid STEM learning. We really wanted to emphasize and engage students with authentic activities, and we also want to provide teachers with differentiation options for teachers. And also, easy organization for our VEX Go VR activities. And you can see we've got extensive teacher support and resources. Yeah. And last, just wanted to show you, we have this PD Plus activity, PD Plus platform, and that's for teachers. After you have, done all the free resources, we've also got this paid VEX Professional Development Plus platform. For teachers, we've got like extensive videos there about, each platform, the pedagogy and how to build robot, how to teach robots, how to teach different platforms, how to incorporate STEM lab. So we've got extensive resources there. I actually wanted to walk you using the real website to walk you through that would be easier. Yeah. So this is the dashboard I mentioned, PD Plus Professional Development. If you click into the video library, you would be able to find all resources. All those resources are for teachers. We talked a lot about engineering design process and engineering notebook, and we have a lot of videos there to help you understand all those pedagogy and other things, and the technical knowledge about each platform as well. Yeah, and also there are free certification course available. For example, let me go to VEX Go because we talk about VEX Go today. We've provided you with free educator certification course. Everything is for you to, self-learning. It's not like very rocket science or something. It's really easy for you to get started. For VEX Go, it's about 7 units. It's like 6 to 8 hours. You can go through all the content, and then there is an exam after that, online exam. And if you have done the exam, achieve like over 70 scores, you would be able to walk away with a certificate. Yeah. So that is the resource I wanted to share with you. I think that's it's what I wanted to share with you, all about our teaching resources and, how to help students improve their STEM using robotics. Any questions? You can type it in the chat box, where you can just unmute yourself. Yeah. Thank you, Omar. You asked, what are the equivalent platforms for VEX IQ? Yes, I will share that with you now. It's the same, education.vex.com. Thank you for the question. Education.vex.com. And all platforms are there available for you. If I know a lot of you are interested in VEX IQ, because that's the level up for VEX Go. We've got the advanced ring and sensors to it is the same. If you go into VEX IQ, all the resources are there as well. The cumulative pacing guide, that's a quick introduction, the scope and sequence for our materials. And you can see for IQ, we've even got more resources. for IQ STEM Lab, because we provide you with different sets of pacing guide, 36 weeks pacing guide, like 24 weeks, or 14 weeks pacing guide, or like 18 weeks, 12 weeks. So different sets of pacing guides there as well. So all those projects, we are standalone, so you don't need to, it doesn't have to finish the first project and then you do the second. No, it's really depends on your curriculum at school, your math curriculum, your science curriculum, and then you can pick the suitable resource for you. It's the same, and all the resources are the same. You can see for IQ, there are different units, projects there as well. Basically, the navigation is similar. We have, different lessons available there. Yep, hope that answers your question for IQ. Yep. Any other questions? And I will be sharing the PowerPoint with you after the session. And if you need the video recording, just let me know and I will send you the video recording as well. And we will be uploading the video recording to our VEX APAC YouTube channel. If no questions, thank you very much. Oh, got a question here. Can we use the pod with the PPTs? Yes. Please feel free to, send the PowerPoints to your colleagues and videos. Yeah, no problem at all. Okay. Thank you very much. And if there are no questions, please feel free to, drop us an email if you got any questions, or, we have the website there. A lot of the key informations there are on our website. Oh, sorry, we got another question from Harry. I've gone through all the free PD and got all 3 certifications. Do I have to enroll for the paid PD? That's a good question. For the certifications, that's help you get started for the VEX products. And for paid PD, there are more functions to it because we have more pedagogy related and technical related videos there for you. And we've also got one-on-one sessions. If you want to talk to our, experts in the US, you can also register for the one-on-one sessions on the paid PD, professional PD platform. And there are other functions. For example, we host annual educator conference every year in Dallas, in the US. And if you have the paid PD, you can join our educator conference every year and you can, meet educators from the world. Yep. Thank you very much. Yep. Thank you very much for your time. Okay. Thank you. If there are no questions, that's it for today. Thanks again for everyone's time. Do let us know if you have any questions through email. Okay, thank you. Bye.